On August 23, 2026, sensors across Venezuela registered 13 earthquakes in a single 24-hour period. This cluster of activity comes exactly 2 months after the devastating June 24 rupture, an event that has left the region understandably on edge. When a monitor lights up 13 times in a day, we have to ask, is this the buildup to a new hazard, or just the everyday background rumbling of the tectonic plates? Looking at the raw tally alone can easily trigger alarm. A number like 13 sounds massive without knowing where or how those quakes are happening. To understand the actual threat level, we have to filter this raw data. We must separate the routine tectonic noise from the true, lingering signals of the June rupture. Seismologists use a strict 3-part checklist to figure out if a new tremor is a direct aftershock, a replica of the main June event. First test, proximity. The earthquake must strike within 40 kilometers of the original rupture zone. Second, depth. Because the June quake was shallow, aftershocks must originate no more than 35 kilometers below ground. Finally, geology. It must sit on the exact same fault system. This is a rigid standard. If an earthquake fails even one of these 3 tests, it is immediately dismissed as an isolated case. Let's run the day's largest event through that filter. At 1:47 a.m., a magnitude 4.5 earthquake struck off the coast of Isla La Tortuga. While it happened on the correct fault system, it struck 173 kilometers away from the June rupture. It completely fails the proximity test, rendering it an isolated event. A few minutes later, 2 more notable quakes, a magnitude 4.1 and a 3.4, registered in the east, near Guiria. Both of these fail the checklist instantly. The first occurred 105 kilometers underground on the Caribbean subduction zone, far too deep. The second hit on the El Pilar Fault, nearly 500 kilometers away from our target zone. The raw catalog also picked up 5 deep-focus quakes from Bucaramanga, Colombia. These shake the regional sensors every single day, but they aren't Venezuelan seismicity, so they drop entirely out of our count. Once we apply the rules, the bulk of the day's most alarming data points vanish. A busy instrument panel does not equate to an active threat to the local rupture zone, but some of the tremors do pass the test. These are the actual signals left over from the June 24 disaster. Take the magnitude 3.4 that hit just west of La Guaira. It checked every box. It was shallow, located squarely on the San Sebastian Fault, and dropped just 4 kilometers from the original break. A magnitude 3.1 strike near La Victoria followed suit, hitting the required criteria for proximity, depth, and fault alignment. Then there is the microseismicity. The monitors captured 6 tiny quakes measuring below magnitude 3, events so small that humans on the surface couldn't even feel them. These microquakes are essential pulse checks. Because 3 of them passed our stringent aftershock criteria, they provide the hard evidence that the San Sebastian Fault is still actively shifting deep underground. This graphic breaks down the final daily ledger. Out of 13 total Venezuelan quakes, 8 were completely isolated tectonic noise. Only 5 were true aftershocks. The scientific takeaway here is clear. 2 full months after the initial disaster, the San Sebastian Fault is still steadily bleeding off its stored tectonic pressure. But there is a vital caveat to all of this analysis. Every single data point we have looked at is retroactive. We are mapping the shaking only after it has already stopped. This flat line represents a critical vulnerability. Venezuela does not possess an early warning network. There is currently no alarm system that will send an alert to your phone before the next major wave hits. Since we cannot predict exactly when the ground will break next, our best defense is understanding the math. By learning how to read the daily reports and filter the real signals from the background noise, we can stay prepared without succumbing to panic.